Hi and welcome to Real World Python Deep Learning Projects by Packt Publishing. My name is Kovakonchik and I've been programming since 1995. Since then, programming is my passion and I really enjoy doing it. And I've been programming in a lot of different programming language and I, built a lot of different kind of systems. And since around 2006, I've started to build a pretty complex Python systems. And what got me really into machine learning and deep learning specifically is that I started to work with a startup that, they wanted to predict future prices of a real estate based on the current prices that they have in the database. And they got me this task of doing all of the research and trying to figure out how we can implement that. And unfortunately, I didn't have enough time to really deep into this problem, and I simply couldn't do that. So then I decided that I want to really get into machine learning and understand how it works, make it really simple for myself and also for others. So this is the goal of this course, to make machine learning and deep learning specifically really accessible for you. So let's go through the course overview. So in this course, you will work with a variety of machine learning problems, and in each project you will learn a distinctive set of tools and how to solve a specific problem with different kind of data and with different kind of deep learning methods. And we'll start with section 1, when I want to give you the essential informations about deep learning so you can get started really quickly. So this section is all about getting you up and running with deep learning tools really quickly. And also I'll show you how you can set up all of the necessary tools really quickly so you can start working with our project straight away. Then in section 2, this is our first project, and we'll start with forecasting how much people will travel by airlines in the next year based on the past data that we have. And in this project, you will learn the basics of building your models and training and testing your models. This will be just a very gentle introduction to how to work with deep learning methods. And by the way, you will learn how to work with time series data and with supervised learning problem. Then in section 3, we'll switch to different kind of data, and in this section we'll focus on working with text and with convolutional neural networks. And here we will learn how to do what we call a sentiment analysis, which basically means that you want to recognize the emotional feel of a text. And here we'll be using a short text or the tweets to do that. You will learn how to prepare your data to work with convolutional neural networks and text, and how to build those models that can tell if a piece of text is negative or not. Then after that, we will switch to different kind of data as well, because we'll start with working with images. We'll still work with convolutional neural networks, but here we will learn how to detect smiles in images. And this is a very common and interesting problem, and you will learn pretty much how to design the model of convolutional neural network for this type of problems and how to purge it, and also how to prepare your data in a way that your training will be quick, which is essential in this section. And then in section 5, we've end with a really challenging problem, which is predicting stock prices using long short-term memory networks. And this is challenging for various reasons, and in this section we'll explore all that and how we can solve those problems to actually get some results. So I hope that you are excited, and one more thing, let's go through some requirements that you have to meet before you can get into this course. So the main requirement is that you have to have some Python experience. You don't have to be an expert, because we basically in this course we're using whole bunch of APIs. We don't use any advanced Python programming tricks. So, the only thing that you need to do here, or to have here, is that you have to have some basic Python experience. And of course, if you have machine learning knowledge or experience, that's a big plus, but I don't assume that throughout this course, and I do my best introduce everything from the ground up as much as I can in the time that we have in this course. So I hope that you're excited about this course. I am, and let's get started. So let's start with opening our preparation script, or to be exact, let's run our preparation script. It's located under prep.py in the source directory for this section. And it will help us understand how our source data looks like and how do we actually need to prepare it. So let's first look at our raw values. So here we have, on the left we have years, and then for each year we have a number of passengers carried by airlines. And this is pretty straightforward data set. And the main question you might have right now is, okay, why we can't actually use this data directly? And the answer is because our neural network don't know what it means, and we need to tell it what it means. So how we can do that? Convert this data and phrase our problem into the way our neural network looks at problems. Our neural network look at problems as a series of observations when you have x and y, and x depends on y in some way. It looks at a list of those mappings between those two values or more, but in our case we need to correlate the number of passengers carried in some way. I'll tell you how in a minute. And then neural network can learn those dependencies between those two values, or a list of two values. So we need to give our network some kind of observation or experience that it can learn on. So how we can do that? We need to generate two arrays or lists. In one array, we need to provide a list of actual predictions, and then in the second list we need to provide what those first predictions are based on. So we have x and y, and here on the right we have the values for each year, and we started with 1973 here, and this is just for illustration. Let's look at those values. So on the right we have for 1973, 4, and so on, we have number of passengers carried. And we can create an x, which is values that we base our prediction on. For each year, we can assume that each year's value depends on previous year's value. So here for 1974, we can assume that the value for 1974 somehow correlates to the value from 1973. The only problem is that with 1973, which is our first year, we don't have any data for previous year that we can use here. So here the previous data will be empty, and we'll have to exclude this particular data point from our x and y because we don't have any way to base our prediction on. So this is the main idea behind the data preparation. We need to construct this x and y arrays, and the values from x will correlate with values from y. And the resulting values will be just x list of values, which are the values that we base our predictions on, and y are the actual predictions. And just try to grasp it. It's a very simple idea, and in both cases we have just number of passengers carried. They are just phrased in a different way. And let's look now at the code that we use to generate those values. Let's open our prep.py script. This is our preparation script. It's located in the source directory for this section. So we are mainly interested in get_data function where all the magic happens. And we are generating those values in 4 stages. The first stage is to read our source data. I'll talk about the details of our source data in a moment, but here we're using pandas. Just read the values from our CSV file, and CSV file is a text file. It's a common separated value file. After we've done that, then we need to convert our values from this file to a numerical values. So here we have values and years. Those two arrays we are producing using getRowXY. The next step is to create our X array, because values in this case are our Y array. Those are our predictions, and then we need to have values that match those predictions or values that we base our predictions on. So those will be the X. We need to generate those X values, and here we call them past values. And when you look at the data once more, when you look at it side by side, you can see that those two arrays, X is just slightly shifted Y array. So when you look at it, this value, the value number 2, let's say, or 1, when we talk in terms of Python arrays, match exactly the value from Y, the first value or the 0 value. And this goes on and on. To generate X, we just shift Y a little bit. So we can look at get_VPO, it's well documented, and we generate those values in pretty standard. The last step is to return those values. So we have years, we need those to produce our graphs, our charts. Then we return our X values and then our Y values. So those are two arrays that we are most interested in. And notice that we are filtering the first row in those arrays, and this is 1 again because we don't have data for 1972 or past data, any data that we can base a prediction for 1973. That's why we need to filter that out, because we don't have data for this particular year. Okay, so let's now talk a little bit about our source data. So our source data is a CSV file, and it looks like this. And it will be located in the source directory for this section in data directory under airlinedata.csv. You can always download this data set just by Googling World Bank airline travel. This is usually how I do it. And then the first result, air transport passenger card, is the right result. And when you go to World Bank's website for this data set, you can download it by clicking on the right under download under CSV. And to use this newly downloaded data, you need to put it into the data folder in the source directory for this section, and you need to rename it to airlinedata.csv. Okay, that's it for now. I hope that was useful. So let's look at our project's plan. So the first step, and this is a very important step, is to prepare our data. And the problem that we're trying to solve here is called sentiment analysis in machine learning lingo. And this step is very important because you will see how when you prepare data in a different way, you will get a different accuracy of our model. So this step is really important. Then we will learn how to build convolutional neural network for text classification. There are a couple of things you need to be aware about that. We'll use so-called word embeddings here, recent invention that allow us to get a really nice results. Then we will train and test our model with the data that we've prepared to find the best model that we can get. And here you'll learn which metrics are important, what you should look for when training and testing your model to get the best model that you can get. And the last step is to actually use this model to detect those tweets, and then we'll explore what we can do even more to improve the performance of our model. So let's look first at our dataset that we'll be using. We'll be using a dataset from SmileD project, and it's open source smile detector. And it uses a traditional methods to detect smiles. And what we are interested most is inside this repository. It's a GitHub repository. We are most interested in smiles directory. So when you go to smiled repository, you can click on this smiles directory, and we have two directories, negatives and positives. And here we have those images that we'll be using to train our network. So how we can install them? So to install them, you have to download the whole repository. So just go to the main page, as you can see here, and you can click on clone or download on the right. When you click on this button, you can choose download zip. When you download this repository, you can unzip it, and you have to copy those two directories from smiles directory, negatives and positive, inside the data directory inside source directory for this section. And I've already done that. Here you can see the source directory for this section, and we have negatives and positives, and that's it. So let's look at how our source data looks like. So in negatives and positives, we have faces of people that are basically smiling and having different facial expression. So in positives, we have a variety of people, basically most of the time smiling. So this is our positives data set. And then we also have negatives data set, and here we have different kind of facial expression. It's not smiling. So even though we have negative and positive, it will fit our project perfectly. And one thing to notice here in those two data set, or in this one data set and in negatives and positives, is that here we have imbalance, because we have around 10,000 negative facial expressions and 4,000 positive ones. But we can work with that, but we have to make sure that we blend together those two data sets so our network will train effectively. So let's now look at our output. And as usual at this step, we need to generate the right X and Y's. So what will be X in our case? X will be the images that we have, and we have to encode those images in the right way. So here I've opened the terminal and run our preparation script, which is in prep.py. And here we have just the first image from X. This is already encoded. So each value that you can see here is the value of the pixel from each image, which is converted, and I'll talk about it in a moment. Notice how each value has its separate array. And this is most often confusing for a lot of beginners, that each value of this pixel have to be wrapped inside a separate list or array. So this is our X, and we are using our input for our network. We'll be using convolutional neural network, and our first layer is the two-dimensional convolution layer. And the input for this layer is 32 by 32 images. In our case, we have 32 rows and 32 columns that we need to provide data in this kind of shape. And we also have to provide the number of channels. And here we're using black and white images, so we can encode black and white just with one value. So we'll be using as channels, we'll use 1. And we generate those values, and we put them inside our preparation script, and then our training script will pick them up and configure our network in the right way. So this is our X. What will be our Y? So here we have our Y. This is again the first encoded class. And here we have just two classes. We have not smiling as 0 and smiling as 1. And here we will be doing things a little bit differently than in previous section, because we'll be using a softmax activation function in the last layer. And that means that we can use more than two categories. And we will still just use two categories here, but I want to show you how you can use multiple categories here with softmax function. And here we have to encode our data in a different way. We have to encode them, each of those classes, as an array or as a vector. And here we have just two classes. So we'll the encoding will look like for 0 we have 1 0, 1 0, and for smiling we have 0 1. And this is the only difference. The predictions will be pretty much the same like previous section, and we have even more options with when we're using softmax when we're doing predictions. I will talk about in a moment. So let's go through the code here. Here I want to highlight bits and pieces that I required, and also bits and pieces that allow us to process data quicker, because this is very important when you're working with convolution neural networks and images, and with images and neural networks in general, because images contains a lot of data, and we want to make sure that we have enough data for training, but at the same time our data is small enough so we can work with it in an effective way. So we'll start with our preparation script. It's located in our source directory for this section. It's in prep.py. And our main function as usual is get_data. And here where all the magic happens. We're starting with loading the data, the negative data and the positive data from our directories, and then for each of those data generating the appropriate label. And we're doing this first for negative samples and then for positive ones. After that, we need to merge them together, join them together, both x's and y's. This is how we do it here. And here we're using a lot of NumPy operations because they are really quick and they work well with images or arrays that we converted from images. Then after that, we hit optimization step. So by default, I got 64-bit values for those images that get converted into arrays. This can work with our neural networks, but it turns out that our neural networks, in our case, we don't need that much data. 64-bit values, they can have a broader range than 32-bit values, but they are larger. It will take more time to actually train our network. So here what we are actually doing is that we are just converting both of those values from x and y to 32 bits, and this will make our training much more quicker. Then the next step is to define the shape of our data, and here we have our input data are 64 by 64 images, black and white images or gray images, and here we just providing this information for our training script when it will define the layers. It needs those kind of information. And then we also need to provide those kind of information about the number of classes for our training script when it defined the last layer with the softmax activation function. And then we need to encode our classes in the right way, and this is the the last output that I've showed you from the preparation script. And here we're just turning our classes into those vectors, those arrays. This is just the requirement of the softmax function. Then after that, to do something with inequality of negative and positive samples. And if you don't do that, if you have imbalance between two datasets, your training will be much more slower. Here we can just use a pretty standard NumPy functions to just mix up the indexes. Indexes will be just distributed randomly. When we do that, we can just rewrite those indexes for both x and y's in the same way so they can both match. And notice that in this getData script, we don't split into training and testing sets, because we'll later on in the training script, we'll let Keras take care of it. Keras will automatically do that for us. So this is the main idea behind preparation of the data. And let's look at our load data function, because this is where we have another set of optimizations. So let's first look at our load data function. So load data just goes through each image and turn it into array. And it mainly does that using image to array function. So let's look at this image to array function. So here it is. It's right at the beginning of preparation script. And there are two things that you need to know about this particular function. So first, it will quite easily turn the images into arrays using imread from scikit image package. This is the required step. This is how you can get those values from the images and turn them just to an ordinary arrays. But after that, there's this very important downsample step. And this is when the next step comes in. This is the optimization step. This is where we turn our 64 by 64 images into 32 by 32, but without losing any important informations. And this will allow us to really much quicker working with the network much quicker and still get the high quality that we're looking for. The last step is that once load data creates all those arrays for each image, it will at the end run prep_array. All of those images turn into arrays. This function does two things. First thing is that by default, the pixel values are in the range from 0 to 255. And this range of values doesn't really work with neural network, especially when you're working with images, because we have a lot of values here. So the good idea is to actually convert each value to a different range, to a range of 0, 0 to 1.0. And this works much more better. So here we can use in a pretty standard NumPy operation and just turn this data into a NumPy array and divide it by 254.5.0, which is the maximum value that we can get in those values, and this will turn those ranges around to 0, 0 to 1.0. And you can still work without this conversion, but it will be much more smaller. And this is not a required step in an absolute sense, but it will make training much more faster. And the last step is to turn those single values for each value that we have in separated list or separate array. This is the stuff that I've showed you when I ran the preparation script. And here we have a quick way of going about it using NumPy. We can just do that on the whole data set really easily. And that's it when it comes to data preparation. So we'll start with downloading data from Yahoo Finance, and this is freely available data, and we'll be downloading it and using it with this project. So the first step to do that is that you need to go to finance.yahoo.com, and then you need to type in the name of the company that you are interested in. In this project, we'll be using the historical stock prices data for Tesla, so you can just type in Tesla here. And once we've done it, we've got all sorts of informations here, but what we are most interested in is the historical data tab. Let's click on that. And when you do that, then on the left-hand side, you have time period, drop-down menu, time range of the data that you are interested in. And we'll be using about a 1-year period data for this particular project. When you choose the time range, you can click on Done, then click on Apply, and then you can download your data in CSV format. And once you download it, you have to put it into the data directory in the source directory for this section under stock_prices.csv. So the data that I've downloaded, this is the historical stock prices for Tesla, and we have a couple of variables here. And we'll be using the same ideas that we've used in section 2 to predict the amount of people that will travel by air in the next year. But the difference between section 2 and this section is that we'll be using multiple variables to do that. So we'll be using a couple of variables that are related to prices. So our data comprise of rows. In each row, we have this information about the prices of a stock for Tesla. The price is in US dollars, and we have the price for one share. our variables that we'll be using is open. This is the stock market opens, this particular one. Stock exchange opens, this is the price that we're starting with. Then we have high. High is the maximum price that this particular share got in this particular day. Then we have low, this is the lowest price. And then we have close price when the stock market closes. And then we also have adjusted close, and we are not really interested in this one because in our case it will be the exact same as the closing price. And then we also have volume. This is the number of shares that were traded in a given day. So we'll be using all those variables apart from adjacent close and data. We'll be using all of those to predict the closing price for a given day. So how we can do that? We'll use the exact same thinking that we've used in section 2. So let's say that we want to predict closing price for this particular day. So we can say that we can use all of the values from previous day to predict this price. Okay? And as you can see, the thinking behind it is exactly like in section 1. We just, phrasing problem as supervised learning problem. That's pretty much it. So we need to convert our data so it can match this thinking. We need to create the X and Y. So let's look at the output of our preparation script to understand also how we can do that, and also how we need to format our data so we can use it with our network. So the first step is to do the shifting, and we can do that with different ways. In section 2, I gave you some idea that how we can do that. The other idea is that we can, when you've got the data for X and Y, so X is the variables, the metrics that we're using for prediction that we will base our prediction on, and the Y is the actual prediction. So when you have those two lists in parallel, you can easily achieve the right format in a way that you can phrase your problem as supervised learning problem just by shifting the Y upwards. It means simply that you're getting value from the first element from Y, and you just discard it, right? Because we are interested in basing our prediction on previous days of metrics. So our first step is to just get the data from our CSV file and create those X and Ys, and without any shifting. So here's how it looks like. This is our X, this is not shifted, right? And we have our Y, this is the closing price. Then after we've shifted that, we leave in the X alone, and we just moving the Y from the next day to the present day. So this is how it looks shifted. So 344 goes up, and we can see that those values are just going up. Those our closing prices are going up, right? And it always takes a little bit of time to get your head around those kind of ideas, but the idea is really simple. And I've got a lot of comments for you in the actual code, so you can read those. I've got some examples there, so I'm pretty sure that it will help you understand what's going on. So once we've shifted the Y and we've phrased our X, Y's in the right way as a supervised learning problem, we need to also shape it so that our network will accept that. And those long short-term memory networks, they work with sequences. Our data looks like that after the shifting. This is just the one element from the data. So here we have just a list of those arrays or lists of those metrics, right? And then in the Y array or list, we have just those values of those closing prices values. We need to convert that into the format that our network will accept. So our network needs another dimension, another list, because it assumes that it doesn't necessarily have to work with just one sequence. And you can imagine that we can add more sequences or more data from more days in the past. And here we're just using one day from the past, the data from the past. So here we just need to add one dimension, which means that we need to just embrace or, put those variables into one more list. And that's it. When we've done it, our long short-term memory network will accept our data. So let's have a look at our data. Actually, when you run this script, it will show us what we will be working with. So here's just a plot of the closing price for our data. So as you can see, in blue we have our training set, and in orange we have our test set. We've split it 80-20, so 80% of data is training set and 20% is our test set. As you can see, this is not an easy to model data because we have a lot of peaks and values, okay? So we'll be working with this data. So let's just quickly have a look at our preparation script to just give you some idea how we can get around it. And it's and 20% is from section 2, but let's just go through it quickly. So we're starting with our main function, which is get_data. This is our main starting point. And then we also have our prep_data. This is the step when we add in this one more dimension to our data set. So let's just get started with get_data. So what we are basically doing here is that we're using pandas to read our CSV file. Then we just getting the right columns from the data and discarding those that we don't need. So we don't need the data column and we don't need the adjusted column. So this is what we're doing in get_raw xy. And then after that, we're shifting this y, right? We're shifting it upwards or backwards, depending how you look at it. So this is what we do with get_VPO. So notice here that we're leaving x alone and we're just shifting y. And then after that, we just discarding the last data at the bottom because we don't have any data there. Because we've shifted y, so we don't have data at the bottom as well. So this is what we basically do here, and all of those functions are pretty well documented, so feel free to go through them and understand what's going on. And you can also go through the section 2 again if you're in doubt and explain it a little bit differently and deeply. So feel free to check out section 2 for preparation data if you're still feel that something is unclear.